When we think of computers and software, we think of laptops, screens, maybe a smartphone app. But computing is everywhere, in your dishwasher, office access systems, and for the last 4 decades, also vehicles. And while your laptop can crash sometimes, your car really shouldn't. So writing software for vehicles, and lately even self-driving ones, needs to be done in a controlled manner. The automotive industry, having been around for more than 100 years, is an intricate system of OEMs, suppliers, standards, and legal frameworks, and the vehicle itself carries more functionality than ever before. Sensors for detecting lane departure might later be used to assist the auto park function. These functions shouldn't get in the way of each other, although they are likely developed by different people. This is just one example. How can we ensure that the companies developing software for vehicles together can ensure safe, secure, reliable, and efficient solutions? That is what Project Synligare is about, collaborating efficiently while developing highly complex software. At first, you have to realize that there is a lot of information to process. A mouse has roughly 120 million DNA base pairs in its genome. A new car has roughly 100 million lines of code in its software systems. And in the development of this software, there are plans, reports, documentation, schematics, test protocols, and so on surrounding it. These information artifacts are sent back and forth between engineers, managers, and all the various experts involved in the collaboration. Each task is performed on a purpose-specific tool, operating on a local copy of the information. Each time that information is sent from one stakeholder to another, there's a risk of introducing errors. Consequently, it's hard to keep the information surrounding the product consistent. Managing large collections of documents has been addressed by making information traceable and by using version control of documents. These are helpful tools for comparing and synchronizing different versions of documents. Introducing model-based engineering, which provides structure and meaning to the product information, is the next step. EastADL, a modeling language for describing automotive systems, is used to encapsulate information surrounding the product, in order to replace the way that various tools represent information. This is a standardization effort that will make it easier to keep information consistent. EastADL complements the important standardization pursuits of AUTOSAR and supports functional safety needs as defined in ISO 26262. In Project Synligare, we've investigated how to collaborate on EastADL models and have improved some existing tools to enable efficient exchange of information. The many dependencies between parts of the software contributes to a complexity that is difficult to grasp. It cannot be easily determined what effect a change in a part of the software would have. Each person involved in the project has their own less than perfect understanding of the product. It's easy to lose overview. The methodology used for model-based engineering tends to encourage the use of modularization, which gives a more manageable structure to the software product. Testing can be done throughout development, catching any integration issues at an early stage. Work can be done on a higher abstraction level and allowing engineers to focus at system content and functionality before implementation. In Project Synligare, we investigated how EastADL can be employed to further give overview over complex information. The impact of introducing a modeling language like EastADL is that now all visualizations can be used in all tools, because the visualizations are adapted to get the information in accordance with the language, independent of which software product it is. So here's the opportunity to bring all kinds of algorithms for finding structure in information and revealing the information in its most comprehensible form. We can bring all these technologies together to support the development of the software product. The fact that EastADL encapsulates critical engineering information means you can automate tasks in a way that was not possible when the information was more task-specific. Calculation of metrics is one good example of how information concerning the whole software product could be automatically processed to give a better understanding. In Project Synligare, we've been able to implement tool prototypes for these concepts and demonstrate these benefits. To summarize, while developing complex automotive software products, it's natural to collaborate with expert suppliers on the design and implementation of core algorithms. Achieving efficient product development means working closely among stakeholders and securing that information exchanged is both traceable and understandable. That is what Project Synligare is about.